Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will teach you the condition of collinearity and coplanarity. Now let's start. What is collinearity of two vector or collinearity of 3 points and coplanarity of more than two vectors? I will discuss you. Now condition of collinearity. Collinearity of vectors. Suppose this is vector A and this is vector B. If collinearity means vectors will be parallel. Vectors will be parallel. So A, B, C are parallel vectors. This is called collinear vector. A, B, C are parallel vectors. So they are collinear vector. Okay. Now what is the condition of collinearity? What is the condition of collinearity? We can write A equal to MB, where M is any scalar. Suppose A is double of B, then we can write M equal to 2. Suppose A is 3 by 2 times of B, then we can write here 3 by 2. Suppose C is equal but opposite, so we can write M equal to -1. So M is any scalar. It may be positive or negative. M may be positive or negative. This is the condition of collinearity. Now another condition, we know angle between two parallel vector is 0 degree or 180 degree. So for collinear, so for two collinear vector, their cross product will be 0 because cross product means A B sin theta. Theta is 0, 0 sin 0 is 0, sin 180 is 0. So A cross B will be 0. So if A and B are two linear vectors, then A cross B equal to 0. This is another condition. Now are collinear A B C. A B C for point for 3 points will be collinear if they lie in same line. If they lie in same line, that is AB. Now same line means suppose A B B C two vectors. So AB and BC along same line means AB may be M of BC. So this condition also satisfied for 3 points to be collinear. For points, they lie must in same line. They must lie in same line. Suppose if 3 points A B along same line and C is another point, they don't lie in the same line, so we cannot AB. So here AB and BC not collinear because they are not parallel. So for 3 points, if they are collinear, then they must lie in same line. They must lie in same line. These are not collinear because these are not parallel. For this case, we must have x equal to 0, y equal to 0, and z equal to 0. So what is the problem about that? Now if A equal to and if A and B are two collinear vector, then this condition must be satisfied. So this is a important formula for solving the problem. This if two are collinear vector, then this by this equal to this by this equal to this by this. How this formula comes? A and B are collinear vectors, so their cross product must be 0. So their cross product must be 0. Now we learn that cross product. How cross product? This equal to 0. Right. I this B1 C2 minus C1 B2 J C1 A2 minus A1 C2 plus K B1 B2 minus B1 A2 equal to 0. So as I, J, K are three non-collinear vector, then their coefficient this and this must be 0. So X, Y, Z. So this coefficient must be 0. From this we get B1 by B2 equal to C1 by C2. Again this 0. From this we get A1 by A2 equal to C1 by C2, and from this that is D2. So from this result, this and this result, we can write A1 by A2 equal to B1 by B2 equal to also C1 by C2. So this way the formula comes. So if two vectors are collinear, then we can write so that the points suppose this is a position vector of a point A. Suppose OA equal to this, OB equal to this, and OC equal to this. So first we find AB vector. AB vector means OB minus OA, this minus this. This is AB vector, and BC vector equal to OC minus OB, which is equal to OC, this minus this. So minus I 4J, this minus this 3J, and this minus this minus 2K. So this equal to minus, take common minus I minus 3J plus 2K. So this minus 1, and this vector I minus 3J plus 2K equal to AB vector. So this is a scalar. So BC equal to MB, in terms of BC equal to MB in this form, a three position vector BC equal to MAB. That means, or AB equal to MBC. So we can say that ABC are collinear vector. Now next is coplanarity. Condition of coplanarity. Coplanarity means the vectors lie in same plane. Two vectors always lie in same plane. Suppose this is A, this is B, A and B. Two vectors always lie in same plane, because we can construct a plane passing through two vectors. Three vectors may or may not lie in same plane. Three vectors lie in same plane or may not same plane. May not lie in same plane. Now, what is the condition of coplanarity? If three vectors be coplanar, this is the condition. If three vectors are coplanar, then A dot B cross equal to 0. ABC are three vectors. We consider. What is the meaning of this? If three vectors ABC lies in same plane, then the parallelepiped formed by three vectors will be 0. This is the actually volume of parallelepiped. This represents the volume of parallelepiped formed by three vectors. Now, how can this represent the volume of the parallelepiped? This is a parallelepiped, suppose. This is a parallelepiped. So here this is B, this is side C, and another side this is another side A. Now BC lies in this plane. In this plane. So B cross C represents around this B cross C, and angle between B cross C and A. Suppose this is theta. We know volume equal to base, area of base into height. We know volume equal to volume of any parallelepiped equal to area of base into height. So area of base equal to B cross C, magnitude of B cross C, and height equal to h. Now what is height? Height equal to a cos theta. This is height. Height equal to h. H equal to height equal to a cos theta. Now B cross C is a vector and A is another vector, so we can write this equal to A dot B cross C. We can write this. So A dot B cross C means volume of a parallelepiped. Now if three vectors lie in the same plane, then we cannot construct any parallelepiped. So its volume will be 0. Now if A1 equal to, suppose A equal to A1I, B1J plus C1K. If A equal to this, B equal to and C equal to what is the result of A dot B cross C? This becomes actually determinate formed by these elements A1 B1 C1 first row, A2 B2 C2 in second row, A3 B3 C3 in third row. If this determinant becomes 0, then we say that ABC lies in same plane, that is ABC are coplanar, and if equal to 0, then ABC are coplanar, and if not equal to 0, then ABC are not coplanar. Simple things. So condition to be coplanarity of three vectors is determinant formed by these elements A1 B1 C1 will be first row, A2 B2 C2 in second row, A3 B3 C3 in third row. The determinant, if the value of determinant will be 0, then these are coplanar, and if not equal to 0, non coplanar. So what is the value of determinant? This becomes A1 into A1 B2 C3 minus C2 B3 minus B1 or B1, this. So this C2 A3 minus A3 A2 C3 plus C1 into this A2 B3 minus B2 B3. So this is the value of determinant, whether these points having reach check the coplanarity of 4 points. This. First, we construct three vectors. Suppose this point is A, OA. Question vectors will be, if this is point A, then OA is this. Suppose OB, OC, OD, ABCD are 4 points whose position vector is denoted by. Now we construct three vectors. AB equal to OB minus OA, that is this minus this. AB vector is this. BC vector equal to OC minus OB, this minus this. Zero. This minus this is minus 13A. Here J is not present, so this minus this, and CD equal to OD minus OC, which is this minus this. Now three vectors we construct the three vectors, these. Now if the determinant of the two if the value of the determinant be 0, then this is three vectors are coplanar, and if are not 0, then these are not coplanar. So this is the condition. So now you can find the value of determinant. So that's why we check the coplanarity points whose position vector. The maximum numbers of vectors. The minimum numbers of vectors of unequal magnitude requires to produce a zero resultant is some option are given. The minimum numbers of vectors. The minimum numbers of vectors of unequal magnitude requires to produce a zero resultant is what? Consider three vectors lies in same plane. Minimum numbers. If three vectors lies in same plane, then the minimum numbers required to produce a zero resultant. Suppose this is a vector A, this is a vector B, unequal magnitude. So the resultant of A and B, suppose this. If we construct a parallelogram, and this is the result. Suppose result of A and B lies in this direction. Now if we consider a vector, if there is a vector which is equal and opposite of that vector, suppose this vector is C and this vector is of A plus B. Now if this vector is just opposite and equal magnitude of that vector, then the result of this becomes 0. So what is the minimum vector required? A, B, C. So answer it will be 3. The minimum vector, that is, suppose A and B are a vector, the resultant of the vector A and B is this. Now if a third vector C exists such that the magnitude is equal and direction is opposite that of A plus B, then this and this cancel, so result is 0. So what is the minimum number of vector required? This and this, such that result is 0. The answer is 3. Means unequal magnitude. Now if you ask that minimum number of vectors of equal magnitude, then what is the result? Then it becomes 2. Unequal magnitude. For unequal magnitude, number of vector requires 3. For equal magnitude, suppose this is A and this is B, just opposite. A and B and opposite, so their resultant is 0. So for equal magnitude, numbers required is 2. If it is asked that equal magnitude, then the answer will be 2. Next problem, the minimum number of non-coplanar vectors required whose sum is 0. Non-coplanar required whose sum is 0. Option is 2, 3. Their answer will be 4. Non-coplanar, that is vector don't lie in same plane. So suppose this is a plane here vector like A and B. If we now what is the direction of A cross B? A cross B is the way. Suppose here C and D, C and D present. So resultant of C and D must be along the diagonal. So this now these cancel this cancel this. So what is the four vectors? What is the number of vector required? A, B, C, D. Four vector which are not coplanar. Four vectors required. Okay, four vectors required. A cross B, suppose in the direction, suppose in this plane along which A cross B lies, you consider two vectors C and D whose resultant is this. So minimum required is this four vectors. What is the result? The minimum number of vector required to sum is 0. The answer will be 2, because if the vector lie in the same plane and equal magnitude but opposite direction, then their sum is 0. So A, this is minus A, so sum is 0. The answer is 2. Satisfy the relation. Three vectors satisfy the relation A dot B equal to 0 and A dot C equal to 0, then A is parallel to these options, which is correct. Solution: A dot B equal to 0, that is A and B is perpendicular, and A dot C equal to 0, that is A and C is perpendicular. That is, here same vector A is perpendicular to both B and C. So we can construct B and C lie in same plane, and if B cross C, which is perpendicular to both B and C, we know B cross C. So the B cross C is the another vector. Suppose this is A vector. If B cross C equal to A vector, then A vector is perpendicular to C. So A dot C equal to 0. Again, A is perpendicular to B. So A dot B equal to 0. That means A vector must be parallel to B cross C. A vector must be parallel to B cross C. This is the answer. So direction of cross product is very important. Suppose B and C lies in a plane. B cross C is normal to this plane. Now B cross C, if this vector is normal to the plane, then this vector is perpendicular to C and perpendicular to B. So that is, if we consider a vector A parallel to the vector B cross C, then this vector also perpendicular to C and also perpendicular to B. That is, A dot C equal to 0 and A dot B. That is, condition is A is parallel to B.